Hey everyone, this is Ms. Johnson here to bring you your Unit 8 Notes 2 on adding and subtracting radical expressions. Today our lesson objectives are to simplify radical expressions, which is what we did in Notes 1, and now, new today, we're going to be adding and subtracting radical expressions. So let's just take a look back at Notes 1 and review what we talked about. Simplifying the square root of 40, I need to break that down into its prime factorization. So I'm going to start by splitting it apart. I'm just going to choose 4 and 10. Remember that it doesn't matter how you initially started, it's the end results that we're looking for. 4 is 2 and 2, 10 is 2 and 5. So that means I have the square root of 2 times 2 times 2 times 5, and I'm looking for pairs. So anything that's a pair can come outside the radical. So that pair of 2's, I have a 2 outside. This 2 is by itself, this 5 is by itself, so that has to stay underneath. And I can put those back together, so it's 2 root 10. For the square root of 50 over 98, 50, if I break that down, is 5 and 10. 5 is just 5, 10 is 2 and 5. So that's my list there. 98 is the same thing as 2 and 49. That's just 2. That would be 7 and 7. So if I rewrite this out, I've got the square root of 2 times 5 times 5, all over 2 times 7 times 7. And I can take out my pairs. 5 can come outside, 7 can come outside. That's 2 square root 2 over, 5 square root 2, and all over 7 square root 2. And then remember, any number over itself cancels. So the square root of 2 divided by the square root of 2 goes away, and I'm left with just 5/7. I'd like you to pause the video right now and see if you can work on number 3 on your own. And we're going to move into adding and subtracting radical expressions. So we need that simplifying piece today as well with adding and subtracting radical expressions. So the first thing you might want to ask yourself is, how do you add and subtract radical expressions? The first thing we have to do is make sure that they're all in simplified form. We have to simplify the radicals. And after we do that, then we have to combine like radicals. It's kind of similar to like terms, okay? Like radicals have the same number under the radical sign. So I've given you a little example for your third box over there. A like radical would be something that has the same number underneath, like 4 square root 5 and 7 square root 5. Since both radical terms have a 5 underneath, they are common radicals or like radicals. Not like radicals have different numbers. So 4 square root 5 and 7 square root 3, 5 and 3 aren't the same thing, so these are not like radicals. All right, so let's look at some examples of combining these things, simplifying these expressions when we have to add and subtract our radicals. So in the first one, I have 2 root 2 plus the square root of 5 minus 6 root 2. And I want to look for anything that I can simplify. If I look underneath my radical, I have the square root of 2, the square root of 5, and the square root of 2. Now those three are already prime, so there's nothing that I can break apart and simplify any further, so I'm just going to leave them as they are. Then the next thing I need to do is look for my common radicals. I have 2 square root of 2 here, and I have negative 6 square root of 2 there. Those two can be put together. It's kind of like saying this is a 2x and this is a negative 6x. Similar concept. They're similar to like terms. So if I put those together, 2 minus 6 is negative 4. So I have negative 4 times the square root of 2. My square root of 2 stays the same. I haven't done anything to the radical. I've just combined the coefficient out front. Now, the square root of 5 is by itself. I can't do anything with that, so I just add it to the end. And that's my simplified term. Okay. Let's try the next one. I have 4 square root of 3 minus the square root of 27. So if I look at those, I'm looking for anything that I can simplify. In this case, I can simplify the square root of 27. So if I break down 27, that's the same thing as 3 times 9. 3 is just 3. 9 is 3 times 3. So I have the square root of 3 times 3 times 3. And then remember, I can take a pair out. So this pair of 3's comes out front to be 1. I have this one left over underneath. So I'm going to rewrite that now simplified. 4 square root 3 minus 3 square root 3. There's nothing that I could simplify with the 4 square root 3 because 3, again, is already prime. So now if I put those two together, 4 minus 3 is 1. So 1 square root 3. Or we all know that multiplying by 1 doesn't change anything, so I can just call that the square root of 3. So I had like radicals there that I could combine. Okay. I want you guys to pause the video at this time and see if you can work on number 6 on your own. So let's move on to number 7. And number 7, I have the square root of 125 plus 4 times the square root of 5 plus the square root of 45. Now, take a look at what you can break down. 125, that is the same thing as 5 times 25, which is 5 times 5 times 5. And 45 can also be broken down. That's the same thing as 5 times 9, which is 5 times 3 times 3. So let's rewrite all that out. I have the square root of 5 times 5 times 5 plus 4 square root 5 plus the square root of 3 times 3 times 5. And now remember, my pairs come out front. So this can come outside, and I have 5 root 5 left over plus 4 root 5. And my pair here can come outside plus 3 root 5. Now these are all like radicals. They all have a square root of 5 underneath, so I can combine all of their coefficients. 5 plus 4 plus 3 gives me 12 root 5. We're going to try one more of these together in number 8. So in number 8, I have 2 square root of 12 minus 3 square root of 27 minus 2 square root of 48. So again, I need to break down anything that I can. I'm going to come over here and break down the 12. That's the same thing as 3 times 4, which is 3 times 2 times 2. I'm also going to break down the 27. That's the same thing as 3 times 9, 3, 3, and 3. And I can also break down the 48. 48 is the same thing as 4 times 12. That's a 4. That's 3 times 4. So there are my lists. Now I'm going to fill those in. So I have 2 times the square root of 2 times 2 times 3 minus 3 times the square root of 3 times 3 times 3 minus, let me get my 48 out of the way here, 2 times the square root of 3 times 4 times 4. All right, so now let's look for the pairs that come out front. This can come outside. So I have 2 times square root of 3. This can come outside, leaving me with 3 underneath. There's a 3 underneath. And the 4 can come outside. Now, when I bring that factor outside, here I brought the 2, here I brought the 3, here I brought the 4. When I bring those out, they're being multiplied with what's already there. So since I already had a 2 out front, I multiply those together and I get 4 root 3. Since I already had a 3 out front, now I have another 3, multiply those together and I have 9 root 3. Same thing at the last one. I already had a 2, I brought out a 4, multiply those together and I get minus 8 root 3. Now these are all common radicals, 3, 3, 3. So I can put all their coefficients together. I have 4 minus 9 minus 8 which gives me, oh, sorry, this should have been a plus. Here we are. 4 minus 9 plus 8, which gives me 3 square root 3. And there we have it. So that's going to end our video for today. I want you to do the one last question, number 9. Pause your video at this time or stop your video at this time and finish number 9. And then when you are finished, don't forget to hop to Schoology and take your Schoology quiz. Hop back to Schoology and take your quiz. We will finish questions 10 through 12 tomorrow in class. Thanks for watching and have a great night.